Welcome, fellow explorers, to a journey through the cosmos, where today we set our sights on two of Earth's closest planetary neighbors, Mars and Venus. These two worlds have fascinated astronomers and space enthusiasts for centuries, but they remain enigmas in their own right. Mars, with its dusty red plains and ancient riverbeds, may once have harbored life. Venus, with its toxic clouds and scorching surface, tells a cautionary tale about the fragility of a planet's climate. Let's embark on this thrilling voyage to discover the untold stories of Mars and Venus, our solar system's extraordinary neighbors. Our first stop is Mars, the red planet. Mars has long captured the human imagination, not just because of its distinctive red hue, but also because of the tantalizing possibility that it might once have harbored life. With its reddish appearance, Mars seems mysterious, ancient, and barren. But this isn't the full story. Let's take a closer look. Mars is a planet of extremes, a world where vast, desert-like plains stretch across the horizon, interrupted by monumental geological features. The largest volcano in the solar system, Olympus Mons, towers over the Martian landscape. Standing nearly 3 times the height of Mount Everest, Olympus Mons is a shield volcano formed by eons of lava flows, with a caldera large enough to swallow the entire state of New Mexico. Beyond these volcanoes lies Valles Marineris, a canyon system that's 10 times longer and 4 times deeper than the Grand Canyon. At over 4,000 kilometers in length and up to 7 kilometers deep, this vast crack in the Martian surface reveals a geological history of colossal tectonic activity and erosion, signs of a planet that was once geologically active. Despite the seemingly barren surface, Mars is a planet of striking seasonal changes. In the Martian polar regions, we find ice caps made of water and carbon dioxide. As the Martian winter comes, the poles freeze, and when summer arrives, the carbon dioxide sublimates directly into the atmosphere. These seasonal fluctuations provide fascinating insight into the planet's atmospheric behavior. On the surface, massive dust storms can engulf the entire planet, lasting for months. These storms, which can be powerful enough to obscure the surface entirely, are evidence of the Martian atmosphere's low density, which makes weather patterns less predictable. But despite these challenges, Mars' thin atmosphere, composed mostly of carbon dioxide, cannot protect it from extreme temperatures, from bitterly cold nights to scorching days. Throughout the years, Earth has sent a number of remarkable explorers to Mars, though not in human form. The Curiosity rover, which landed in 2012, has been investigating the Gale crater, uncovering signs of ancient water flows and the possibility that the region once hosted microbial life. But the curiosity doesn't end there. In 2021, the Perseverance rover arrived, tasked with investigating Mars' Jezero crater, a site where scientists believe a lake once existed. Perseverance is searching for signs of past microbial life, collecting rock samples that could one day be returned to Earth. But that's not all. Perseverance is also joined by the Ingenuity helicopter, a technological marvel that made history in 2021 as the first powered flight on another planet. This tiny rotorcraft has expanded our understanding of what's possible in planetary exploration, offering us an entirely new way to study Mars from the air. Millions of years ago, scientists believed Mars was much warmer and wetter. Evidence from rovers and orbiters suggests that rivers once carved valleys into the Martian surface, and ancient lakes and seas may have filled vast basins. If liquid water once flowed here, could life have existed as well? These discoveries fuel the ongoing search for signs of ancient life. But why did Mars lose its water and become the cold, dry planet we see today? The answer may lie in its smaller size and lack of a magnetic field, which left it vulnerable to solar winds. Without the protection of a strong magnetic field, Mars' atmosphere began to erode over billions of years, slowly losing the heat it once retained. As a result, its water evaporated, leaving behind a world with only traces of its past. However, Mars still holds clues: frozen water at its poles, underground ice, and minerals that form only in the presence of liquid water. Understanding how Mars lost its atmosphere and became the dry desert we see today could teach us invaluable lessons about Earth's own future, especially in light of climate change. Could Earth face a similar fate if we don't act to protect our atmosphere? Now, let's travel closer to the Sun, to the second planet, Venus. Often referred to as Earth's twin due to its similar size and mass, Venus is a world that couldn't be more different from our own. Though it shares many similarities with Earth, its surface is an extreme, inhospitable hellscape. Venus is completely enshrouded in thick clouds of sulfuric acid, making it impossible to see its surface directly with visible light. These clouds reflect sunlight, giving Venus its distinct yellowish hue and making it the third brightest object in the night sky after the Moon and the Sun. The atmosphere is so thick and dense that it causes a crushing pressure, equivalent to being 900 meters underwater on Earth. But it's the intense heat that truly defines Venus. Venus holds the title of the hottest planet in our solar system. Despite being second from the Sun, Venus experiences surface temperatures around 465 degrees Celsius, 870 degrees Fahrenheit, hotter than the surface of Mercury, even though Mercury is closer to the Sun. This extreme heat is the result of a runaway greenhouse effect, where thick clouds of carbon dioxide trap heat and prevent it from escaping into space. The result? A planet so hot that it could melt lead and burn any spacecraft or equipment that tries to land. Venus' surface, though largely hidden from view, is mostly made up of vast volcanic plains interspersed with impact craters and mountain ranges. Evidence suggests that Venus may have had active volcanoes in the past, and possibly even active ones today. However, unlike Earth, Venus' surface lacks plate tectonics, the dynamic geological activity that helps regulate the temperature on our planet. Without plate tectonics, Venus' internal heat is trapped, which could be one of the key factors contributing to its extreme surface temperature. But Venus wasn't always like this. In fact, scientists believe Venus may have once had a more temperate climate. Billions of years ago, it may have had oceans, a more stable atmosphere, and mild temperatures. Could Venus have supported life in its ancient past? Or did its runaway greenhouse effect happen too quickly for life to form? The mystery of Venus' transformation is a central question for planetary scientists as they work to understand its history. Despite the impossibly harsh conditions on Venus, scientists have managed to send probes to its surface. The Soviet Union's Venera missions in the 1960s and 1970s made incredible breakthroughs. Venera 7 became the first spacecraft to transmit data from Venus' surface in 1970, and other Venera missions sent back the first photographs of the planet's rocky surface, revealing a landscape littered with volcanic plains and impact craters under a thick, yellowish sky. These findings were groundbreaking and continue to shape our understanding of Venus to this day. Though both Mars and Venus are similar in size, they could not be more different in terms of habitability. Venus is a world of scorching heat and crushing pressure, with a thick atmosphere that suffocates any chance of life as we know it. Mars, by contrast, is a cold, arid world with signs that it may have once been a more hospitable place, capable of sustaining life. Both planets tell a unique story of planetary evolution, each offering lessons about what can happen when conditions go wrong, and how small changes in a planet's environment can have catastrophic consequences. As our exploration of Mars and Venus continues, we are reaching new heights in technology and discovery. NASA's Veritas and Da Vinci Plus missions to Venus will explore its surface and atmosphere to unravel the planet's past, and upcoming missions like Mars Sample Return are preparing to bring pieces of Mars back to Earth. With the possibility of human missions to Mars on the horizon, the exploration of these planets offers not just scientific insight, but also the potential for future human colonization, should we ever need to expand beyond Earth. Mars and Venus, two worlds that share a similar size and a place in the solar system but have taken dramatically different paths. Through continued exploration, we'll unlock the secrets of their histories, and in doing so, gain a better understanding of our own planet's future. These two planets, with all their mysteries, may hold the key to answering some of the biggest questions we've ever asked. Could life exist elsewhere? How did our own planet evolve? And what can we do to ensure a sustainable future for Earth?